kilogram object is to be pulled to the top of a 6-meter high ramp by a rope, the other end of which is pulled by an electric winch. The ramp forces a 30-degree angle with the horizontal. The coefficient of kinetic friction between the ramp and the object is 0.6, and the coefficient of static friction is 0.8. The object moves up the ramp at a constant velocity of 3 meters per second. On the diagram,
Yeah. It's a constant velocity, okay? I'm just gonna change all of those numbers so that I don't appear to help you as much. Okay, so the height of the ramp is 4 instead of 6, right? The angle is, it's a double angle. The mass, I'm just gonna go ahead and reduce the mass to half. So what would be my mass?
it would be 40 kilograms.
So you reduce that one?
Mm-hmm.
Is you reduced?
No,
Okay.
I can't reduce, but you're reducing it.
Oh, yeah. So, you know, this is from long time ago, last year. You're gonna tell me how many forces do we have in the x direction or parallel to the plane?
We have. Is that tension from the rope?
I'm just telling you the plane. So, what's the force? The first one is the weight, right?
Mg.
Okay. What is this?
Mg cosine.
What is this?
Mg sine.
Since the object is accelerating. Okay, is the object accelerating?
No.
How do you know?
Cause it says there's a constant velocity.
So constant velocity means a is equal to 0, you know. That's kind of common sense.
Mm-hmm.
You need that, that's very important for you to know. Okay. So basically I have this force right here, right?
Yeah.
And the force of tension.
Yeah.
What else do I have?
You have
Okay.
force normal.
Okay, normal force. What else do I have? Remember I tell you the coefficient.
Oh yeah. The static friction
Yeah. Which means the object has friction. So
going down.
okay. So now we're gonna use what? This is the note right here.
Wait, do we use static friction or kinetic?
I'll tell you just make it better. Okay. I want you to use the teacher guideline material that I give to you, I appear to give to you. Where that on the last page. So what does it say?
It doesn't tell me anything.
As you can see, the reading itself doesn't really tell you because teacher has some higher knowledge. The student should have some knowledge.
Mm.
Okay, it's okay if you guys don't have it. By now, we use Newton's second law of motion, right? Can you tell me the formula?
F equals ma.
Sigma F equal MA. So now I'm just gonna do that one for the vertical one first, which is parallel to the plane, right? Which is these two forces. So, you know, when we're only looking at the vertical, which is perpendicular to the plane, what have you concluded?
They equal each other.
They equal each other out, but why?
Oh, because the acceleration is 0.
Okay, acceleration is equal to 0.
Yeah. So it's force normal minus mg cosine equals
Okay.
0.
Minus mg, right? Okay, tell me again why this part right here is 0.
Because there's a constant velocity.
No,
There isn't?
this is vertical.
Oh, because there isn't any velocity in the vertical.
Because the object is not at rest, but they're not
It's not going up.
something up, one down. Okay. So there's currently there's no motion in the vertical direction, right?
Yeah.
Okay. So that would be N equal to mg cosine. You're gonna need that one when you figure out the forces in the y direction. So I'm gonna do the parallel one. This is MA, right?
Yeah.
So let's talk about all the forces acting upon this box. How many forces do we have?
3.
3. What's the first force?
Force of tension.
T. Remember, you only do sum of the forces. And now, since force is a vector, tell me direction.
Negative. Right.
Negative,
And
negative, right? Because they're going that way. What's the first force that slows the motion down?
mg sine.
Second,
The kinetic
equal to?
equals to ma.
Okay, but we know A.
Yeah, a is 0.
A 0 because
There's constant velocity.
constant velocity. As you can see, both sides of the equation here, they have the same thing, which is 0. Do they have the same reason?
No. Oh, kind of.
No, they're not.
Yeah.
Okay, differentiate between those two different reasons.
So the first one, the reason why it's 0 is because the block isn't moving
Okay.
upward.
Mm-hmm.
It's only moving on one plane.
Yeah.
And then the second one, there's a constant velocity, so there's not going to be an acceleration.
As you can tell, these two things, reasoning to tell you what the first law of motion is. What? Sigma F is equal to ma. Sigma F is equal to 0. For both cases, constant what?
Velocity.
Velocity. And what at rest? Is it at rest or constant velocity? Which means some of the forces become 0. There are forces, but they're just 0. Now, okay, now tension is equal to what?
mg cosine. Or wait, isn't that sine?
Yeah.
mg sine.
Why?
plus- Oh, because that's on the
That's right,
plane.
right?
Yeah.
Okay, we mg sine plus.
FMF.
Okay, replace this one with.
Static.
Remember friction? Yeah, normally you always overcome the static friction force in order for the object to be moving. So that would be mu. What's the n? The normal force in this case is
mg cosine
mg cosine equal to
0. Or no, yeah.
now what else do you do based on my thing? Okay, now your task to determine the power. So can you tell me what is the formula for power?
Oh, power equals force times velocity.
Power is equal to force times
Velocity.
nope.
It's not-
Power is equal to work divided by time. First is entire knowledge.
Oh, yeah.
And work is equal to what?
The work is force times distance.
Force times distance, then over time. So from earlier one, that long ago, velocity is equal to distance divided by
Time.
that makes it force times velocity is equal to power. And also from equation, what is given? Distance or time or velocity.
The velocity.
That's why they force you to use this formula. You see, this AP test is not as easy as you thought.
Wait, they give you the force, right?
They give you the force, which they don't give you the force.
They
You
don't.
actually have,
Or you have to find the force.
yeah, by using what law?
Second law of motion.
And
Newton's
also,
second law. And the first law.
yeah, and everything, basically use your brain to begin with.
So for that one, do we use the tension as force?
Yes, so that would be force of tension times velocity, which give you the power. And then,
Total amount of work.
Okay. I'm not gonna give you any more guidelines. That's it. How many minutes? Done.